When using a temperature heat source, the thing you're going to do the most often is set the temperature. We've made setting the temperature on the field metrology well very easy to do. We have a dedicated set temperature point button which allows you to simply press the button and set the temperature. Just to give you a demonstration of how easy that is to do, let's go ahead and set the temperature here. So as you see on this front panel, we have the set point temperature. We've dedicated a button just to allow you to set the temperature. So you go ahead and press that, press enter, and then you enter the desired temperature that you want. In this case, let's go to 0 degrees Celsius, as that's a common temperature for us. So do that, press enter to enable the controls, and now we're going to temperature. Now why this moves to temperature, let me talk to you a little bit about what we have on the, the front screen of the field metrology well, and then I'll take you a little bit into process electronics. If you look at the very top of the field metrology well display, you see you have in the big numbers, this is our control temperature of the dry well. Now down inside the block of this dry well, we have a sensor that's controlling its temperature very accurately and also making it very stable when it gets there. That's the temperature that you're seeing here as we're cooling down in temperature now. Moving down one line, all the way to the left, you see is the set point temperature. Now you see this is 0 degrees Celsius, because that's what we've set it to. And so you know that's the direction we're headed and the temperature we're going to. If you move straight across from there, you see that we have cool and then a percent. That percent correlates with the power bar underneath it and will fluctuate. Now this is useful for you to know the direction it's heading and what the controller is doing. If you move down right below that, you see that little squiggly line? That's our stability indicator. That's another very good feature that we've built in the metrology well. The benefit there is that you're not having to sit and wait and wonder, is my dry well or is my metrology well stable? That stability indicator is squiggly right now, indicating that it's not stable. When it stabilizes, and by the way, you can set that stability criteria to be just about whatever you want, but when that stabilizes, that squiggly line will turn into a flat line, and then it'll beep at you, letting you know that it's reached temperature and that it's stable to the criteria that you've set. Right down below that, you'll see we have ref ... and then TCK ... Now that will only appear there if you have the process electronics. That's the ability here in this case that you're reading a reference probe or a thermocouple, which I'm going to show you here in a minute. And so that's kind of an introduction to the screen. You have your basic block temperature, your set point temperature with some information about the power, percent heat, percent cool, stability indicator, and then your reference temperature and the unit under test temperature for your process electronics option. Now moving on to the process electronics, we looked at what the field user was doing. What tools are they having to take? What instruments are they having to take to get their job done right? Well, we made the process electronics so you don't have to carry so many tools out into the field. There's obvious portability benefits there, but you also have it all very accessible on the front panel. And so what are some of the tools that you're replacing here? First of all, you might be taking a documenting process calibrator out to the field, or a temperature calibrator in which you're needing to measure current or milliamps, and so we looked at replacing that by allowing some documentation features built into the firmware and the ability to measure a 4 to 20 milliamp transmitter in these two ports here. So that allows you to do that. What else? Well, you might be taking a reference thermometer readout and a reference thermometer probe into the field. Well, the readout we've taken care of with our built-in reference thermometer readout port here and the ability to read a thermocouple or unit under test. And so we've essentially replaced the need to take a 2-channel thermometer readout and documenting process calibrator out into the field by going with the field metrology well process option. So what is the process electronics? And what are some of the benefits and how do you use them? Well, the first thing we want to take you through is a reference thermometer, being able to connect a reference thermometer and measure it. Now, as we're moving down in temperature here, you'll see we're getting close to getting there. Here I have a PRT. Now this is an ITS 90 PRT that's been calibrated and is very accurate. Within the connector of this PRT is a chip. That chip has its programmed calibration constants for this individual PRT. The benefit there is that you're not having to connect it up and then enter all the coefficients, which may be 7 or 8 digits, 4 on each line that you'd have to go through and enter. You simply plug it into the front panel here, and as you'll see on the screen here, we're starting to read temperature. It automatically recognizes the probe and begins to read the temperature. And now I've got it sitting on the desk here, so we're reading ambient temperature, but it immediately recognizes that. So what about your units under test? We've got the reference probe covered. Maybe you need to calibrate some unit under test and you want to do it all in one instrument. Here I have a Type K thermocouple. As you can see on the front panel, and there we've beeped and we're at temperature already. See, that didn't take us very long at all.